Okay, this is my video for homework 5, question 1. The question is, x and y are independent with fx is ux minus 1 minus ux minus 2, and fy is uy minus u minus y minus 1. And another random variable z is x plus y, and we have to find fz, that is the density function for z. And we have to do this in two ways. The first one is to use the convolution method to directly calculate the convolution with this function. And the other one is to use the geometric method. Here's my answer. Okay, we're going to start from the direct calculation of convolution here. So basically this is the fx and this is the fy. Looks like these. And fz can be directly calculated in this way. We put the functions inside, and then we calculate. We gotta break this down and break it into 4 parts. Part 1, these two multiplied. Part 2, this times this. Part 3, this times this. And part 4 is this part times this part. And then we calculate them independently. We calculate the 4 integrals. And we put it down to 1 to z, 1 d alpha, u zeta minus 1, z minus 1, and this, and this, and this. That is the 4 parts of this big integral. That is a direct calculation. Quite easy to retrieve here. And that is z minus 1 times u z minus 1 minus 2 times z minus 2 times u z minus 2, and plus another z minus 3 times u z minus 3. And according to the hint, we can, when we are calculating the geometric function, geometric method, we can first calculate another function of these two convoluted. That is to replace this x, the original x, with a new x. That is fx equals ux minus ux minus 1. And we can shift the result to the right by 1, by unit 1. So we are going to calculate this one first. Calculate this new fz. Big fz is probability for big z smaller than small z, and to substitute it, we have to calculate it in 2 parts because we know that both the functions are like this. That's the new function we're calculating. For z smaller or equal than 1, we can find that this is the straight line for x plus y equals 0. That is y equals minus z. So we have to find that x plus y smaller than z. This is the line for this inequality. And we say that this is c. We can find that the integral here, the probability here is basically the integral of small f, the density function in this area. But we can know that it is 1 in this area, so basically the fz of z smaller than 1 is basically the probability of x plus y smaller than small z, and basically it is the area of this shaded area. That is 1/2 z squared. And we take derivative when find the small z, that is solely z. And the second part is for z between 1 and 2. In a similar way, we can find the area of the shaded part. It is this triangle subtracted with this small triangle and this small triangle. That is 1/2 z squared. That is this part minus 2 times this small triangle. The 2 times 1/2 z minus 1. That is this part squared. And we can find a form of this. And then we can find the small f and take derivative. Take the derivative of the big F. You find that it is negative z plus 2. So we can combine this function in this part and this function in this area. So we get this. And we write it in one line. Basically like this. And then we simplify down to this form. This is the same. This is not the same yet. We have to now shift the result above to right by 1, and we get the final result. This final result is the same with the one we get from the previous question here.